guys? Welcome back to Daily Ed, where you get smarter daily. In this video, we're going to discuss a fairly simple physics problem involving integration. Now, before we go into that, let's recall the concept of integration graphically. So we got position time graph, we got velocity time graph, and we got an acceleration time graph. Let's say that this one looks something like this one looks something like that, this one looks like that. It doesn't really matter. Now, in order to get velocity from an acceleration time graph, we must remember that we have to get the area under the curve of an acceleration time graph. This gives us velocity. Now, if we want to get the position of in a velocity time graph, we must do the same. This denotes position. You have to remember that integrals work backwards and derivatives work forward. So if we wanted to work the other way around to get derivatives, the derivative of this line would give us the velocity, and so on and so forth. Now let us dive into this problem. So this problem says tells us to consider the plot describing motion along a straight line with an initial position of 10 meters. We have an initial position of 10 meters. Now, we can denote this, actually not V naught, excuse me, X naught, 10 meters, correct? Now, we have a graph, but this graph is a velocity time graph. As we recalled, getting the area under the curve of a velocity time graph gives us the position. Now this problem is asking, what is the position at 9 seconds? So our 9 seconds is right here, our initial is right here, from 0 to 9 seconds, after 9 seconds, right? And we have an initial position of 10 meters, and we cannot forget that. So, in order to do that, we must remember how exactly to get the area under the curve. Well, we just use areas. In this case, we have a series of triangles that we can use and a rectangle in order to find what the position is. So for example, here we have this big right triangle. With 90-degree angle. Right here we have another right triangle, 90-degree angle. Here we have a rectangle. And here also we have another triangle with 90 degrees. Notice how this triangle, however, is under the x-axis. Whenever there is an area under an x-axis, that means that we have to subtract this area from this area. So first, let's look at our values. First let's look at this rectangle. We have 1, 2, 3, 4 base times height for this one. We have a 4 and we have a height of 6. Therefore, this is 24 meters squared. For the triangle, we know that it's base times height divided by 2. Now, the base is 1, 2, 3. The height is 4. 4 times 3. That's 12 divided by 2, 6, correct? Now, we have another triangle here with a base of 2 and a height of 6 plus 3, 9. 9 times 2, 18. 18 divided by 2, we got 9. So we have 6, 9, 24. Now let's look at this one. We have 1, 2, 3. We have 1, 2, 3, 4. Same thing. 3 times 4 divided by 2, 6. So what happens then? Well, notice how we have to add this and subtract this. Notice how this is a 6, this is a 6. We just forget about these two, and we focus on the area right here. So we have 24 plus 9. When we add 24 and 9, we get 33. At first glance, you might say, well, that's my position after 9 seconds. However, remember that the problem said that our x naught was 10 meters, so we have to add that to 33. And that gives us 43 meters and a position, and that is our position after 9 seconds.